Hello everybody, welcome to my video projects illustration series. This is the first one in the series. My name is John, and what I'll be doing is just kind of demonstrating some previous work. The one that I have here on the table is very recent, and what it is exactly is I was approached by a client of mine to restore the data or read the data that is on this punch paper tape. I'll move in to see if I can get you a better view of it. This is a very early means of data storage. Okay, this if you can see, there is a row of very small holes here. Those holes are your syncing, data clocking holes, and the larger holes, there are 8 of those, and each horizontal row of holes represents one numeric byte of data. And this technology probably dates back to, I'm going to say it's probably 70s. 70s was probably when the format was at its most popular. It was still pretty popular in the 80s, and eventually as PC computers became more readily available and more popular, it replaced this method of storage. So my client, who has a CNC machine shop, this was a very popular method for storing your CNC programs back in the 80s. And also, not just the part programs, this was how they stored their machine's parameter settings, which is the tape that I'm holding in my hand. This is something crucial to restoring a CNC that has died because of motherboard failure or RAM failure in the CNC. So this is why I'm being asked to do this. They don't have the means to read the tape. Fortunately, they did actually own the parameter tape. So my project was to get the data from the tape and into the laptop. And over the years, collecting parts, and I managed to come across this punch paper tape reader head, and it's extremely simple in principle. It's basically this stepper motor driving right straight on its output shaft this sprocket, which pulls that punch paper tape through. And on the lid side, you have infrared LED diodes, and on the bottom side you have infrared phototransistors. There are 9 of each. So what I'm going to show you is the methods that I've used to interface the punch paper tape reader head to this laptop computer, and we'll go ahead and get started. Alright, well, the first thing I like to do is apologize for the tidiness factor, or lack thereof. This is, like I said, a very recent project. Finished it, just hours before filming this. And so, I've just got it to the point of usability. And it will, in fact, probably remain only that. I don't really see the need. I don't really see a huge demand for reading tapes and converting them to text, but you know, it's here and usable. If I should have another call for it, I can easily get it up and going without a nice, real pretty, fancy project case. It works just like it's shown. So, that being said, let's focus on this interface board. This is actually this here. This is a single board microcontroller computer with a Motorola chip of some kind, Motorola processor, and I was able to salvage 5 of these from machines in a junkyard. And this is actually, this paper tape project is actually the 3rd one that I've employed use for since saving all of these, and my reluctance to throw anything away has made all this possible. So it's got inputs here, and over here it's got outputs hidden by this ribbon cable. The ribbon cable has replaced the microprocessor socket. It comes out in ribbon form and goes to the back of the computer to the parallel port. And the outputs on this board are driven right off the parallel port on the data port. The inputs are taken from the printer port's control and status lines, and then in the computer program they combine to make a 8-bit number. So that being said, let's see, we should move maybe to here. This, again, not so neat and tidy. What we have here is 3 chips. We have 2 quad operational amplifiers and 1 single one in the middle to make 9 op amps with a variable resistor for adjusting a threshold setting is primarily what that's there for. I won't get too technical, but basically that allows the LEDs on this guy to communicate properly with the inputs of this board. And now we'll come over here and talk about the software, which is basically a command prompt driven software. You type in a command and the reader will follow it. The command for fast forwarding a tape is FF, it's not case sensitive, RW for rewind, BOT for beginning of tape, and GD for get data, which will start the tape rolling and start reading it in. And that's pretty much the extent of the software. As you can see, the tape is now loaded in the path of the tape reader, and over here on our board you can see that we have 1 LED on, and that would be the strobe channel or sync channel that I was talking about earlier, the smaller hole on the tape, and that the reader head in fact actually has a view of that hole right now. None of the rest of the LEDs are on, and that is because this is blank tape. This is the leader section of the tape that we have threaded through here. So I'm going to now move to the laptop, and we're going to give it the command to read the tape, which is GT get data. And when I press the enter key, you can see the stepper motor is phasing, and here comes the data represented on the LEDs, and the screen over here is also scrolling with the data that has been found. Okay, we're nearing the end of the file, and there it is. And now the software has just prompted us to enter a file name along with a drive and directory path if necessary. We're going to call this one C:\video.nc. And then I forgot to mention also that this tape is not ASCII as it comes off the tape. It has to be converted to ASCII. The format is actually EIA, which is a number system that it's probably forgotten about. It's probably not in use anymore. ASCII has probably replaced it. But so the software has to run some number crunching, and there is the program that it deciphered from the tape. And we're done with the software. And I believe this is going to conclude the video. Thanks for watching.